Hey guys, this is the third section of chapter 9, so 9-3. There's gonna be a second video tomorrow night. It's gonna be part 2. This is gonna be part 1. So this is part 1 of 9-3. Tonight we're just gonna call it circle biology, just because we're gonna talk about the parts and the meaning of a lot of the parts of a circle, and then we're gonna actually apply it to another example. So first thing I'm gonna ask you to do is do your best, draw a circle. Now, if you have trouble drawing a circle, here's what I recommend. Take a paper clip or some type of string thing, like you've got a lantern that you keep your keys on. This little hole right there, that would be actually perfect. Let me show you that. That little hole hook right there, that would be perfect to put a string onto, and then I would just keep your finger down, like try and wrap it around your finger a little bit, and then draw a circle using that. So that would be a really neat way of doing it. If you've got tape or a paper clip or something to help you do that, do your best. First couple things you're gonna notice right off the bat, the center I've called C because it's the center of the circle, and I've got a chord drawn here also. We're gonna talk more about that in a minute. I want to talk about the definition of what a circle is. A lot of people will think, oh, the circle's this whole thing, like all the inside part. That's not actually true. The circle is the case around this empty area. Because that's the empty area, that's the area of the circle. So, first thing I'd like you to write is what the definition of a circle is. Circle, a figure created by a set of points that are all equidistant, they're all the same distance from a common center point. Okay, so go and write that down right now. So, the circle is created by all these points, this point because it's equal, it's that far away. This point because it's the same distance, this point, this point, this point. It's made by all those different points that are all the same distance from this center point right there. Those points make the circle. This doesn't make the circle, this just defines it. And this chord isn't part of the circle either, it's just attached to it. Okay, so that's pretty major for definition. This is actually it's a pretty tricky one. So let's just go through some things that I think are rather important. I'm AB, so I'm just going to highlight that. This guy right here, that is a chord. It is attached on two parts. It touches the circle in two different parts, the endpoints touch in two separate parts, and so that's a chord. So when you write it down, if I asked you to write down what all the chords are, you would just write down A, B, put a line above it, because it's a line segment. Okay? Let's talk about, I'm going to draw another chord. I know you're going to say, hey, wait, that's not a chord, that's not what I know it's called, but hold on, I'll talk about that in a minute. Let's call that guy, let's call him X, and let's call that one Y. And you're going to say, wait, that's a chord also? Isn't that the diameter? And yeah, it is. That's totally true. The fact is this, the diameter is a chord. It is a special chord. Here's a few things. The chord, XY, goes through the center, that's why it's the diameter, and it is the longest, the biggest possible chord that can be made. If you notice, it is longer than AB right here. So, I'm going to put that, I'm going to go comma, and I'm going to say XY is also a chord, but it is also a diameter. Okay? And it's a line segment, that's why I'm using the line segment symbol right there. Radius, oh man, let's add some more. Yeah, let's take this guy. Let's draw that as a radius, and let's draw this guy as a radius. Now, how many radius do you see? Let's count. We got 1, 2, 3, 4. Remember, radius is half a diameter, and those are horrible looking lines, but we'll just talk about that later. The radius is half the diameter. So it is in the middle of xy, and if you notice, every single time I'm going to write cx, because that's a chord, that's a radius. I'm going to write cy, that's a radius. CB, that's a radius. CA, that's a radius. And if you're noticing, what point does every single radius get labeled with? The center point. So whatever the center is, that has to be used when you name that radius. Always. And that's it. All the radius are always the same. Okay? And, sorry, I'm going to yawn a little. All the radii are always equal length. So whatever distance from here to here, C to X, that's the same as C to B, no matter what. So radius, really awesome using. Okay, so you want to finish writing all that down if you need to. Chord AB and XY. XY is a diameter. CX is a radius. CY is a radius. CB is a radius. CA is a radius. Lots of radius. Radius are usually more common. Okay. Ready for this one? Here we go. This is our one and only example we're doing today. So this is going to be a real short example. So I'm just going to call this example 1. I take that back. There's 2 examples. I lied. 2 examples. This is example number 1. I'd like you to copy this figure. It's a circle. Kind of looks like a square, but it isn't. You might say to yourself, man, 1, 2, 3, 4, 5 points. There's not much here. Oh, you wait. You wait, my friend. He's going to eat those words. I'm just going to go crazy. Here's a chord, W and X. Here's another chord, X and Y. Here's another chord, Y to Z. Here's another chord, Z to W. Those are all chords. Oh, we're not done, my friend. That is a chord, and that is a chord. So how many chords do we got? We got 6 chords. Here we go, writing them down. X, W, bam. X, Y, bam. Y, Z, bam. Z, W, or WZ if you want to be alphabetically correct, but bam. Oh, I thought there were 6. You're right, there are. X, Z is a chord, and W, Y is a chord as well. Get psyched. What about diameters? Well, there's only 2 of those. We already named them, WY, XZ. Please draw that a little bit. I'm going to do that. I want to do that again. We got time. That's better. That's better. Here we go. So what do we got? WY and XZ. There we go. Those are diameters. Now radii. They have to start here in the center. So I'm going to start right there. I'm just going to keep my pencil. I'm going to go, where's 1, 2, 3, 4. Here we go. We got the CW. Get it? Never mind. CX. CY. And CZ. And then CY. Never mind. A lot of information, a lot of questions we come up on that. Let me just do this. This will be funny. Trust me. Never mind. So, those are all chords. There's 6 chords, 2 diameters. Man, let's write that down. 6 chords, 2 diameters, 4 radius, all in one picture. Lots of information, huge topic. So, there you go. Lots of questions that can be answered on that one. So here's our picture. We just named everything, just real quick, a little run through on that and naming stuff. We're going to be doing that tomorrow. Okay. Let's do a challenge question. I'm bored. I wanted to do a little fun one. Using the figure below, find the area. By the way, this is example number 2. Using the figure below, find the area of the square. So it's going to be a square created by the centers of the 4 congruent circles. The radius of the circles of the radius of every circle is 5 centimeters. So that's going to be a little bit of a hint. So this is my lovely picture I've drawn. Here's my recommendation: take a quarter, outline like 4 quarters, and that would be the best way to go. I made a little mark. This is 5 centimeters. And what are we looking for? We're looking for the area of the square. Right there. Okay? So we're looking for that guy who hates Todd Packer. 2 thumbs. Who's got 2 thumbs and hates Todd Packer? This guy. Okay. It's a square. So how long is it? Well, we know this radius is 5. Well, if that radius is 5, let's put a point right here, a point right there, a point right there. A point right there. If that radius is 5, all of these, that's 5, and this is 5, this is 5, and this is 5, this is 5, and this is 5, this is 5, and this is 5. All those sides, all those blue lines are 5. But if I make them all 1, 5 plus 5 makes 10 centimeters. Which means this has got to be 10 centimeters because it's a square. Every side's equal to 10. Wow, right? Crazy. Like, that little information that every radius is 5, every radius is 5. We expand on that because this whole thing right here is 10. Crazy. Well, let's start for our equations. Area of a parallelogram. It is a square, but we're going to go with parallelogram because that's what we're using nowadays. Base times height. 10 times 10 is 100 centimeters squared. And that's the area. Not much work. Not much work done for this. This is actually very little mathematical computation, writing and stuff. But you just got to think about how that would work for this. Now, I really want you to copy this picture. Do a real good job copying this picture, please. Because it is going to be an awesome question that I'm going to ask you sometime tomorrow. And it's a really neat question. So, we'll talk more about it tomorrow. That's it for notes today. Circle biology. It should all be review. So this is all stuff that you should know about. So come ready tomorrow. Okay, good night's sleep. See you tomorrow.